This whole meeting reminds me of the Department of Environmental Sciences I was at the University of Virginia, in which we required that our students pass calculus-based courses in hydrology, atmospheric science, geology, and ecology. So we had a great diversity, and as a result, the graduates of our department were invariably smarter and better educated than the individual faculty. And that's what I hope will come out of this. First, I want to talk to you about some basic global warming science. First of all, it's been known since the late 19th century that the response of temperature to carbon dioxide is logarithmic, so that for every new increment of carbon dioxide we put in the atmosphere, the actual temperature rise becomes less and less. This is an important fact. Finally, the increase in carbon dioxide is assumed to be a low-order exponent. And in fact, if you look, that means it's an ever-increasing compound interest curve, but at a very modest compound interest. If you take a look at the carbon dioxide history from Mauna Loa, you can see measurements began in 1957 at about 315 parts per million, and we're running about 385 parts per million carbon dioxide right now. The exponent has been remarkably constant. You hear carbon dioxide is accumulating in the atmosphere at an increasing rate, etc. Yes, it is. The increasing rate is 1/2 of 1% per year. Our computer models generally use between 0.75 and 1% per year increase. So it might not surprise you that the models tend to predict a little bit more warming than is being observed. That will become very important in this talk in a little bit. Anyway, this may shock you. If you add up an exponent and a logarithm, you can get pretty close to a straight line. And you have spent probably about $10, $12 billion in the science community, and we have completed an exercise that you would do in pre-calculus. You will see what happens in our computer models is that they tend to predict constant rates of warming. File that, because that's a piece of reality that is very important. Whenever you hear someone say, the planet is increasing, warming at an increasing rate, that person is going against the body of our computer models. The models predict constant rates of warming. And when we look at the rate of warming, we're going to see that it has been surprisingly constant. Now, one thing that bothers me immeasurably about this issue, if you went to your car and turned on the radio, there would be somebody in the radio this afternoon that's going to say there's no such thing as global warming. And if you go on the internet, you're going to find somebody who's going to say, global warming is the end of the world unless we do something now. The truth of the matter lies in between these two things. That's where we have to imagine our solution. The world is replete with calls for its end, as you know. And the world is replete with people who completely deny the existence of certain phenomena. Reality lies in between. Now I want to show you that the warming that we're seeing is in fact a greenhouse warming. There are two major greenhouse gases that we're putting in the atmosphere. Carbon dioxide and methane. But what they do is they supply a small amount of warming, and then they increase the amount of water vapor that's in the atmosphere. Water vapor is a very powerful greenhouse gas. If you warm up the ocean a little bit, there's a little more evaporation, and so you get more water vapor in the atmosphere. Remember that logarithmic curve I showed you? The first increments of carbon dioxide or water vapor will produce the most warming. So if I found a place on Earth that didn't have very much carbon dioxide, and we didn't have very much prior to the Industrial Revolution, and didn't have very much water vapor, like land areas and cold places in the northern hemisphere. You know it's very dry in the winter. That's why people use skin lotion up north. Let's take a look and make a prediction. We'll say that the dry land places should be warming more than anything else if it's a greenhouse warming. This is the warming in the cold half of the year. The map is flipped 6 months at the equator. Not quite that stupid. Anyway, you can see how the red and the bright warming concentrates, in fact, in the land areas and in the more northerly land areas in particular, where there's a lot of dryness. So we have a greenhouse warming, okay? Anybody who says on TV or on the radio that we does not know what they're talking about. And so we also imagine solutions. Here's a solution, the Waxman-Markey cap and trade bill. It would limit emissions 2000 to 2005 levels in 2012, 16% below that in 2020. By the time we get to 2050, 39 years from today, emissions will be 83% below where they were in 2005. This is a graphic of emissions per capita that are allowed under Waxman-Markey. If you take a look, here's 2005. the reductions here go out to 2050. We are mandating that you will have the per capita emissions that the average American had in 1867, 39 years from now. Do you think anybody knows how to do this? Well, one of the things that's related to is economic growth. We'll hit that 2005 target in 2012, no problem. These are US CO2 emissions over here. There's 2005, 6, 7, 8. 2009 isn't in yet, the numbers aren't in, but they're going to be below that line, below the chart. Why? Because the economy crashed. So, lesson one, this is not cheap. In fact, what would you get for all this? Here are the temperature changes that would occur for the Waxman-Markey legislation. Number one on the left is we don't do anything. We just continue where we are. This is according to the United Nations main computer model, what they call SRES scenario. You get about 1.58 degrees of warming by 2050. That's from 2000 to 2050. US passes Waxman-Markey, 1.54, 4/100th of a degree of saving. The entire world that has obligations under the Kyoto Protocol do Waxman-Markey. The entire world, Canada, Europe, Asia, not India, not China, they're not going to do it. You get 1.5 degrees. So you save 8/100ths of a degree of warming for Waxman-Markey. This is on out to 2100. And the numbers are very similar. It doesn't do anything. Even if all the nations of the world that have obligations under the Kyoto Protocol do something. Now you have to imagine a solution that's different, don't you? Here's the cost estimates for Waxman-Markey. You know why? Do you know how to reduce emissions 83%, total carbon dioxide emissions? The three most important words in life are not I love you. They are I don't know. And neither do you. We can mandate things, but that doesn't mean they're going to happen. And because of the unknown cost, that's why the Senate is running away from Waxman-Markey. It's not going to pass. And so we transition now from Congress to the Environmental Protection Agency. The Environmental Protection Agency issued a finding on December 7th that carbon dioxide was an endangerment to human health and welfare. And they relied in general upon two reports, one of which was from the United Nations Intergovernmental Panel on Climate Change, their so-called fourth assessment report. I did a considerable amount of work for that report. And it contains, this is the linchpin of EPA's endangerment finding. Read this. Most of the observed increases in global average temperature since the mid-20th century are very likely due to observed increases in anthropogen-generated greenhouse gases. In other words, carbon dioxide and methane. Very likely. They say that means 90 to 99% probability under their rubric, and most of the increase in temperature. You know what? When that statement was made, I agreed with it. And that put me in the horrible middle in the world of climate change. Yeah, I believe most of the increases in CO2, in fact, or in temperature are related to CO2. I did in 2007 or 2006. Then some remarkable things happened. This is the temperature history, by the way, from 1950, the last half century that they use. This is from the Climate Research Unit at East Anglia. I'm not going to talk about ClimateGate. The observed increase in that record is 0.7 degrees total. It's at about 0.117 degrees Celsius per decade. Okay, that's fine. Well, it turns out since then, same people at the CRU discovered an error in the measurement of sea surface temperatures in the World War II and post-World War II era that raised the temperature from what they thought it was. And so now the blue line is what the temperature has been adjusted for, given that error in the sea surface temperature. It's now 0.55 degrees or 0.09 degrees per decade. Then, this is my own work, McKittrick and Michaels, we took a look at problems with measuring temperatures in land areas, not just cities grow up around thermometers. Everybody knows that. Do you know why all weather stations are painted white? So that they do not absorb excess radiation. And when the weather station gets dark or dingy or dirty, the temperature gets warmer. How high on the food chain do you think painting the weather station is in the economy of Chad or in Africa? And so the signal degrades. And we found artificial warming in the in the surface temperature records for the land areas only. It's published in Journal of Geophysics Atmospheres in 2007. So we now adjust the temperature rise for that, and it drops to 0.46 degrees. The trend is now 0.08 degrees. Then Susan Solomon, just last month on the National Academy, published a paper showing, wait a minute, there's an influence of the temperature from water vapor in the stratosphere that we didn't consider before. Remember the science is settled? Holy God, she just put in a whole new variable in the computer model. And when you adjust for that, you wind up with 0.4 degrees of warming and a rise of 0.06 degrees. Finally, Jacobson out at Stanford studies what we call black carbon in the atmosphere, black particulates that go in along with the carbon dioxide, and they have a warming effect. And he subtracted those out from the temperature record. And here's what you get. You now get, whoops, I went the wrong way, sorry, pardon me. Black carbon, you now get 0.3 degrees of rise, and the trend at 0.05 degrees per decade. Guess what? The EPA's wrong. The IPCC was wrong. In the course of time, between when that IPCC report came out and now, these remarkable findings, these are mainstream literature findings, have knocked down the warming so that the central tenet of the endangerment finding is not there. I'm as shocked as you are, okay? I didn't believe this until not very long ago. So anyway, when all the known influences are put in fact, more than half the warming disappears, and therefore their statement is incorrect. Fine. What does that tell us about what we're going to do for the future? Well, we can make some estimates on future warming. First of all, let's think of the implications of the failure of the EPA assertion. What's going to happen is that their endangerment finding is going to be challenged in court. And it's going to go on and on and on forever. We're not going to pass Waxman-Markey. EPA is going to get mired in this huge suit. So, what does that mean? What's going to happen to U.S. emissions? Nothing. Okay? Nothing in the short run. But what about the long run? This colored spaghetti here, each piece of colored spaghetti is a computer model. One of the things that you see, the solid black line, are the averages of all the computer models. This is from the United Nations Fourth Assessment Report. This is what's called the mid-range carbon dioxide emissions scenario. We're actually running a little bit below that. And one of the things you see is when you average them all up, it's a straight line, right? You add up a logarithm and an exponent, you get a straight line. You look at the individual models, they're straight lines. So how do you decide which of these models is correct? Well, you have something called reality. It's the same problem that comes up in the daily weather forecast. I would tell students, look, if the NAM model says this low pressure system is going to produce rain and the GFS says it's going to produce snow, what do? Look out the window, okay? Which model is working best? Well, you have a climatic window, don't you? You do have that temperature record, not just from the CRU. There are other temperature records. Yes, we can talk about, that's another subject, all the problems that are going on in the business, but our dirty linen is being washed in public. I wish everybody else's would too. We'd see there's a lot of it. At any rate, one of the things we could do, here's a close-up of the models, by the way. I want you to take a look at the bright green line, and you'll notice that these models can actually produce coolings in them, even as CO2 is increasing. And it's a fact that temperature hasn't done very much for the last 10 years, but still the overall warming is very, very linear. Now, you want to look out the climate window with me and see which model works? Very simple. There you go. The warming trend since the late 1970s is so obviously linear. And anyone who says that the planet is warming at an increasing rate does not know the temperature records. The planet is warming at a constant rate. Some very, very bright minds in this business made a lot of computer models. They all tend to share the same characteristic. They have constant rates of warming. What does this tell you? Well, we've just learned a lot of things. Number one, it's not warming as fast as you thought it was. It's not warming as fast as I thought it was. Number two, if we take the collective wisdom of our models and we say the collective wisdom is that they predict constant rates of warming. Is there a constant rate of warming? Yes. Then we can project the rate of warming for the future. How nice. And it looks relatively modest. This is very, very good news, but it doesn't mean you can't or should not do anything about this. In fact, you are doing something about it, and many of you don't even know what you're doing about it. You invest your money in companies that produce things efficiently or produce efficient things compared to their competitors because they produce things more cheaply and more efficiently. Now, if we had Waxman-Markey, we don't know how much it costs, but remember this. When gasoline was $4 a gallon, last time it hit that, U.S. consumption dropped a grand total of 4%. How high does it have to be to drop consumption by 83%? I don't know. Famous words in this business. Now, that's going to take a lot of money that you would not invest. However, if we let you have that money, you might do this. And watch what the world did. This is the stock price, where they are concurrent, for 3 automobile companies. And I just updated it 19th of February. I would have General Motors on here, GM, but they went bankrupt. The top one is Honda. The next one below is Toyota. Stock tip. All the Toyota scandals, when it hits 50, buy. Ford, generally perceived to produce relatively inefficient cars compared to these 2 competitors. Stockholders did not invest in this company. They have begun to invest it. It's got a tick up there in the end as the company has become more efficient. If we took this money away from you, you would not have been able to invest it, and it's happening around the world. I agree with the previous speaker on investment capital, but I will tell you this. If I take your money away in a futile attempt to stop warming, which is Waxman-Markey, we will get to the world that we want, a more efficient world, a cleaner world, a world of less emissive technology. It will take us much longer to get there. The future belongs to the efficient, and you will not get to that efficient future unless you have a vibrant economy. Thank you very much.